Assalamualaikum and a good day, student. This is a recorded lecture on second chapter. So this second silo is entitled multiple integral. Okay, so this multiple integral is all about the double integral or triple integral. Okay, I'm going to share my screen. Okay, regarding the multiple integral. Okay, so what is the meaning of multiple integral? So the multiple integral can be divided into the double integral or triple integral. So the process in this multiple integral is just an extension from a single integral. Okay, I believe that you have been familiar with the single integration. Okay, but for now we are going to see how we can evaluate the double integral, or and also for the triple integral. Okay, but when we work with the multiple integral, so you have to know about the coordinate system. Okay, I'm going to show to you example regarding the multiple integral. Okay, but I will share to you something regarding the double integral. Okay, so this is the double integral symbol. Okay, so let's say if we want to evaluate okay, xy, and we have this dy dx. Okay, so let's consider this is as indefinite integral, so there will be no limit. Okay, so this is symbol, there is double integral symbol. So this is an example for the double integral in terms of dy dx. Okay, so in order to perform this integration, you are supposed to do the one in the internal part. Okay, so this is in the internal part. Okay, so we have to integrate xy dy dx. So we do the integration with respect to y variable first. So the other variable will be assumed as the constant. Okay, so this answer for the integration will be okay, y squared over 2 xy. Then we have another integration in terms of x variable. Okay, so at the first part here, we do the integration with respect to y variable. Okay, and then we continue integrate with respect to x variable. Okay, so we look at this x variable, the other part will be assumed as the constant. Okay, so here to proceed, we are going to integrate x with respect to x variable. So we have x squared over 2, then we are going to times this one. Okay, and then plus the constant. So we can combine the numbers. So the answer for this double integral will be x squared y squared over 4 plus constant. Okay, so we can switch. Okay, we can switch or perform the double integral as follow. Xy dx dy. So if we have this kinds of example, we do the integration with we do the integration with respect to x variable. Okay, because we have internal part here dx, so we do the integration for x variable first. Okay, so the first integrations here we are going to have x squared over 2y. So this y will be assumed as the constant. Okay, then we have this part. Okay, so this is the starting step when we start integrating with respect to x variable. Okay, the second one. Okay, so we are supposed to perform the integration with respect to y variable, right? Okay, so here we are going to integrate with respect to y variable. So this part will be assumed as the constant. So we integrate y. So it becomes y squared over 2. Then we are supposed to multiply the other part that we have here. Okay. And plus the constant. Then we simplify the numbers. So here we have x squared y squared over 4 plus constant. Okay. So here, as you can see, either we are performing dy dx or dx dy for the same function. Okay. The final answer at the end here is equivalent. Okay. It is the same answer. Okay, so no matter whether we are evaluating dy dx or dx dy for the same function, at the end the answer is equal. Okay, so I will just provide example for the double integral. This is for definite, right? Okay, so this is for indefinite integral. Okay, so for the definite, when you have the limits, okay, you just proceed the same thing. Okay, evaluate the value. We do the same thing how we perform the evaluation for definite in single integral. Okay, so definite means that there will be a limit. Okay, for example here 0, 1, 1, 1. So this is example for definite, but the one that I provide to you here is indefinite integral. Okay, so if it's given here, for example, in this double integral, so at first part here you are supposed to substitute when y0, y1, right? Okay, so get the value and then there will be no more plus c. Okay, so just next one you have to evaluate when x is here 1, 1. So there will be no constant. So if there is indefinite integral, so the final answer should be plus constant. If there is indefinite integral, there will be no more constant, but you have to evaluate at the certain limit. Okay, so for the coordinate system, okay, so I have provide to you the example regarding the double integral. So you have to know and you should be able to perform the same thing into the triple integral. Okay. So now we are going to see about the coordinate system. Usually this multiple integral, whether it is double integral or triple integral, there will be application in engineering. Okay, so the problems related to the multiple integral in engineering will be lies on the coordinate system. Okay, so there will be a two-dimensional coordinate system or it will be three-dimensional coordinate system. Okay, so the one that I showed to you in this slide, um, we have polar coordinate. So this is actually example for two-dimensional coordinate system. So this is 2D. Okay, this is 3D. And this is also 3D. Okay, we have exactly XY as Cartesian. Okay, there's another 2D. We call it Cartesian or the second name we call as rectangular. Okay, rectangular, this is 2D. So the form will be XY. So this is basic form that I believe you have been familiar with this XY coordinates, right? Okay, but in the coordinate system, it is called as Cartesian or rectangular coordinate system. So this XY coordinate system can be transformed into different coordinates. So Cartesian or rectangular can be represented in polar. So the transformation will be given here. Okay. In polar coordinates, so we have XY in Cartesian. So in polar, it is called as r theta. R means the radius. Okay, radius from the origin. So basically this polar coordinate will following circle equation. Okay, circle equation, the standard form is x squared plus y squared equal to r squared. R refers to the radius of the circle. So this is basic equation for the circle. Okay, so this is in Cartesian. So in the polar, it will be x equal to r cos theta, y is equal to r sin theta. So y is in Cartesian, r theta is in the polar coordinate. Okay. And for the 3D, we have also Cartesian, or we call rectangular, but it is in 3D. Okay, but the coordinate will be written as x, y, z. Okay, this is basic form. So this Cartesian and rectangular can be converted into cylindrical or spherical coordinate. So the transformation is given here. X in Cartesian is rho cos phi, y in Cartesian is rho sin phi. So z is equal to z. Same thing in this cylindrical. And for the spherical, this is the transformation. Okay, so we are going to see the multiple integral one by one, starting with two-dimensional, and then we move forward to the three-dimensional. Okay. Okay, so this is basic double integral. Okay, this is basic double integral using Cartesian. So you can see dy dx. So fxy refer to the function. R refer to the region. R is okay, this R. Okay, so this is in Cartesian. Double integral in Cartesian. Then this will be the double integral in polar coordinate. Okay, polar coordinate. So we can convert Cartesian to polar. We can convert polar to Cartesian. Okay, so it is two ways situation. And this is basic formula that you are supposed to be familiar. That's the one that I showed to you just now. Yeah? And this is basic equation for the circle. So the radius can be calculated using here. Okay, so the angle theta can be calculated using inverse of tangent function. Okay, we are going to see example for this. Okay, so the example you can see from ebook of Paul Dawkins, the one that I have teach in the e-learning. Okay, so I will just select two questions here. Okay, 1A. Okay, this is the first example for double integral. So this is an example regarding double integral in Cartesian. So dA refer to the area. Double integral, so this dA means the area bounded by the axis. So it can be represented in Cartesian as dy dx. Okay, so in the question, they give you the limits. Okay, so R is the region. This is the limit for x-axis followed by the limit for y-axis. Okay, so got example here. The function is 6xy squared. So if we want to do the integration, first by y-axis, okay. So this limit should be, the internal one here should be the limit for y-axis also. Okay, so to integrate, we do for y first. So y squared, when we want to integrate, it becomes y to the power 3 over 3. So over 3, simplify with 6. Okay, so then you will get 2xy power 3, right? Okay, so this is the step. After that, take note that we have definite integral, there will be limit. So this is actually the limit for y. Y equal to 2, y equal to 1. Okay, so we evaluate the upper limit first. So you are supposed to substitute this one. Okay, let me show to you the detail. Okay, so this is the step. We want to evaluate, okay? This is actually limit for y. Y equal to 2. Here is y equal to 1. Okay, so we have this integral. We are going to evaluate. Okay, first one, the upper limit. 2 power 3. Okay, 2 power 3 is 8. Okay, then we have to deduct with the one that containing lower limit, y equal to 1. So 1 power 3 is 1. Then we have minus 2x. Okay, then we have the x. Simplify the one in the bracket first. So we have 14x, right? Okay, so 14x. So now we proceed. Integrate respect to x variable. Here we have x squared over 2. And then we have 14. Okay, so simplify. So we have 7x squared. Then we evaluate. This is actually limit for x4, x2. Simplify before substitute the value. Okay, so here we have 7x squared. Then evaluate x4, x2. Okay, so x squared, first one, upper limit. 4 squared is 16. Okay, then we times 7. We have 112. Okay, and then minus 2 squared is 4. 7 times 4 is 28. Okay, so final answer is 84. Okay, so this is a definite integral for double integral in Cartesian. Okay, so note that we have the other way to do. Okay, 6xy squared. You can do also dx dy. Okay, when you change dx dy, okay, so the limit here also you have to change. Okay, so this limit, this is internal part containing x variable. So this limit will be x2 and 4. Okay, limit for y will be here 1, 2. Okay, so you can do this double integration. When you evaluate this double integral, you must get 84 as the answer. Okay, so please verify this step. So if you don't get that 84, and please ask me, okay, about your steps. There will be a mistake if you didn't get equal value. Okay, so you may verify for other question, this one. If there's any part, I think the issue here, if you don't get the answer, will be your method to integrate. Okay, so I think that's all. Thank you.